in 1862 to 1947 observed that when ultraviolet radiations were allowed to fall on the emitter plate of the evacuated glass tube enclosing two electrodes or metal plates, the current flows in the circuit. As soon as the ultraviolet radiations were stopped, the current stops flowing. These observations indicated that when ultraviolet radiations fall on the emitter plate C, the electrons are ejected from it, which are attracted towards the positive collector plate A by electric field. The electrons flow through the evacuated glass tube, resulting in the current flow. Thus, light falling on the surface of the emitter causes current in the external circuit. The minimum frequency at which the electrons are emitted from the metal surface is called as the threshold frequency. The minimum frequency depends upon the nature of material of the emitter plate. Here you can see the experimental arrangement for the study of photoelectric effect. No more. It consists of an evacuated glass or quartz tube having the photosensitive plate C and another metal plate A. Monochromatic light from the source S of sufficiently short wavelength passes through the window W and falls on the photosensitive plate C, that is emitter. The electrons are emitted by plate C and are collected by plate A, that is collector, by the electric field generated by the battery. The battery maintains the potential difference between the plate C and A. The polarity of plates C and A are reversed by the commutator. When the plate A is positive with respect to emitter plate C, the electrons are attracted towards it. The emission of electrons causes flow of electric current in the circuit. The potential difference between the emitter and collector plate is measured by the voltmeter V, whereas the resulting photocurrent flowing in the circuit is measured by microammeter, that is mu A.